Assalamu alaikum again. Here we'll talk about perpetuities and annuities as continuation of chapter 5. As we talked about multiple cash flows, if you remember from the previous slide, you saw that each cash flow had a different amount. Like in our example about the car, we said that 8,000 now, 4,000 in the next year, and 4,000 in the year 2. So basically you will notice that here the cash flow amounts are different, so we call them as multiple cash flows. However, sometimes in some scenarios we may find that the amount of cash to be received or paid at every future period is same. Okay, so if it is the case, then the cash flows, instead of calling them as multiple cash flows, could be called as annuity or perpetuity, depending on two important things. Both our annuity and perpetuities are level cash payment. That means the same amount of cash payment in every period. But in perpetuity, this payment never ends. That means it goes on forever. Perpetuity, it goes on forever. While for annuity, again, it's a level stream of cash flows at regular interval with a finite maturity. That means you know when that payment is going to end, maybe for 5 years or 10 years or 20 years. But in a perpetuity, it goes on forever. Now with that context, we'll have a look at the formula to calculate the present value of a perpetuity and present value of an annuity. So first thing, let's look at the PV of the perpetuity. For the PV of the perpetuity, basically, since there is no T, the formula would be C, that is the amount of cash flow. Note that for a perpetuity, it's the same amount of cash flow. So C over R, R stands for the interest rate. So in this case, suppose you have to create an endowment. Is like maybe a waqf which you create. So maybe you want to create an endowment which pays $100,000 per year forever. Now the word forever itself means that it is perpetuity. So you will notice that it is 100,000 per year. That means same amount of payment regularly forever. It means it's a perpetuity, so we can apply the perpetuity formula. So it's asking how much should you set aside today. So that means they're asking you for the present value at the rate of interest 10%. So you would be applying your formula CD over R. C is the cash flow, that is 100,000. R is the rate of interest, that is 10%. So 0.10. So you would say that if we keep aside $1 million today, it can create an endowment which pays $100,000 per year forever. So there is a twist to this particular question. What if the perpetuity will not start until 3 years from now? So it's only a matter of discounting that cash flow for 3 years. So if we were to show a timeline, let's say this is today 0. I'll put it here. Let's say year 0. And then year 1, year 2, and year 3. The question says it's still a perpetuity, but the payment will only start from the 3rd year. So it means I want to know how much should I keep aside today. So you need to notice that the calculation that we did in the previous slide of $1 million would have been required if the payment of perpetuity were to start immediately, that is in year 3. But now if I'm going to start the perpetuity after 3 years, it means I need even less money today. So basically I just need to apply a simple cash flow problem for calculating the PV. So I say FV, that is 1 million, divided by 1 plus R to the power 3. 3 is 3 years, after which we will start receiving the money. So it means today I just need $315, which I'm going to invest at 10% for 3 years. And at the end of 3 years, this would have become $1 million, which could generate an endowment of $100,000 forever at 10% interest rate. Next we'll go to annuity. Now the case about annuity is a little different. Here we would say that annuity actually is referring to the same amount of payment over a fixed period of time. So we know the amount, the year, the number of periods in the time. Here you will use an annuity factor. If you will notice what is here, this part which is in the bracket is called annuity factor. Now annuity factor is nothing but the amount that you're going to multiply to your cash flow in order to get the present value of your annuity. So once you realize that the cash flow is referring to an annuity, you can apply this formula, and the formula is C, that is the cash flow amount, that is your cash payments, 1 over R minus 1 over r into 1 plus r to the power t, which refers to the annuity factor. So let's see the use of this annuity factor. So basically, if I want to use this, let's say it basically says how much will $1 generate. I mean, what is the present value of this $1 which you're going to receive each of the year for the next T years? So I would say the present value of the annuity factor, we refer to it as PVAF, is 1 over r minus 1 plus r to the power 1 over r into 1 plus r to the power t. So basically this part of your PV formula is called the annuity factor. For example, let's say you're purchasing a car and you're scheduled to make 3 annual installment of 8,000 per year. So if the interest rate is 10%, so what should be the price of the car? That means what should you be paying today? That's the idea. So it's asking you what is the PV. So I use the PV formula. I would use C, that is 8,000, and 1 over R minus 1 plus 1 over R into 1 plus R to the power T. And when we solve for it, we receive 19,894. That is the value of all these payments that you make for the next 3 years. 8,000, 8,000, 8,000, and the value of it today is 19,894. Basically what you're doing here is you're discounting the first 8,000 payment for 1 year, the second 8,000 discounted for 2 years, and the third 8,000 discounted for 3 years. Now instead of doing that individually, we could use the annuity factor to solve for it at one shot. Okay, so this is the same answer that we got in the formula in the previous slide. Where do you use this perpetuity and annuity? So basically, in any mortgage payment, let's say you took a loan with a mortgage and the bank calculates equalized monthly payment, which we call it as EMI. So there the concept of annuity factor or the annuity will be used. So basically you use it for calculating the value of your payments, your implied rate of interest for an annuity, and also for calculating the mortgage payment, the annual income from any investment payout, or even the future value of your annual payment. Now if for this last point, that is the future value of the annual payment, basically you can use the formula that is first calculate your PV of your annual factor, and then compound it to the required amount. Because can you see in the previous slide we saw the calculation of the PV, and the formula for the PV is PV of the annuity. This would be the formula C into uh, present value factor, present value of the annuity factor. Then if I want to know the future value, I just need to use that amount and compound it for the number of years. For example, here, let's say you plan to save $3,000 every year for the next 4 years, given an interest rate of 8%. What will be the future value in your account? So that means you will be investing 3,000, 3,000, 3,000 for the next 4 years. And then the question is, what will be the FV? So first step, first calculate the PV of the payment of 3,000 for the next 4 years. So if you can see here, we are applying the formula C, that is 3,000, into 1 by r minus 1 by r into 1 plus r to the power t. You apply that and you calculated the present value. So this is PV of the annuity, and then you apply the future value or the compounding factor, that is 1 plus r to the power t, and that will give you the future value of all these payments at the end of 4 years. Another example here, let's say you're purchasing a home and are scheduled to make 30 annual installment of 10,000 each. So I want you to identify here. Notice that in this question, C is 10,000 and 30 is the time, that is the number of payments that you'll be making each year. R is 5%. So what is the price you're paying for the house? That means what is the value that you're paying today? In other words, what is the PV? So you will just apply the PV formula. So C into 1 plus R minus 1 over 1 over r minus 1 over r into 1 plus r to the power t. Solve for that and you will get the value that it is 153,724.51. The payment for 30 years equals not even half of what payment you made for today. Let's take another example. So let's say you plan to save for 50 years and then retire. given a 10% interest rate, if you desire to have 500,000 at retirement, how much are you going to save every year? So can you see, just like we had found that if any values in the equation is missing, you can solve for it. So notice that here the future value is given, that is 500,000, but they haven't given us um, the present value. So we could solve for that by putting C, which is missing in this case. R is given 10%, and the number of years is also given 50. Please correct that. That is 50. Okay, so when you solve this equation, you will get 529.59. Some other concepts here related to annuities. The first one is called annuity due. No, now you have to note that uh, by default, annuity means that uh, annuity refers to the payment will start at the end of the first year. But sometimes, if you would want to calculate the payment to be starting immediately, then the term that you use to refer is called as annuity due. It is a level stream of cash flow which is starting immediately. It's different from an annuity because annuity, the payment starts only at the end of the first year, and the formula also differs a little bit. Basically, it's similar to if you want to calculate the PV of the annuity due, you first calculate the PV of the annuity and then just compound it for 1 year. That is 1 plus R. So how does the future value differ from an ordinary annuity? If at all you're going to do the future value, then basically you will do future value of an annuity due is equal to first do the future value of an annuity. Remember, we can derive this formula from the previous slide if you saw it, and then again you're going to compound it for 1 year. So basically the difference between annuity and annuity due is that one basic initial year, where in the annuity the payment starts at the end of the year, while for annuity due the payment starts immediately, maybe at the beginning of the year. Let's take this example. Suppose you invest 529.59 annually at the beginning of each year at 10% interest. After 50 years, how much your investment would be worth? So basically, we're trying to find out what would be the future value of an annuity due, because you're saying beginning of each year. This refers to annuity due. So first thing is, first calculate the future value of the annuity and then multiply with 1 plus R. So let's use the formula for annual future value of the annuity due. First you solve for future value of the annuity, which is C into the annuity factor. This is the annuity factor into the future value. Future value for 50 years. This should be to the power 50, and then you multiply 1 plus R to get the value of your worth of your investment today. Same thing you can, this slide just shows that you could solve the same any type of problems by using your formula. This one we have already solved. It's just illustrating how you can solve the same using calculator rather than the formula. Also this question where you're talking about the payment for 30-year period, so you're taking a mortgage out for $100,000 and you will pay back over 30 years, so you want to know what is the monthly payment. Now one thing I would want to add here, the monthly payment means they're asking you what is the C. In the calculator, the PMT button refers to the annuity amount, that is the same amount of payment over a period of time, that is the month per month payment or something like that, or payment per month or something like that. So basically you need to push that button to get the values. You could use the spreadsheet also to solve for PV of the annuity or PV of the annuity due. Finally, we'll talk about a small concept here, which is effective annual interest rate, which is also called EIR, that is effective interest rate. It is an interest rate which is annualized by using compound interest. Now sometimes when you have a contract, or maybe you have a instrument which is giving you maybe a monthly interest rate or a semi-annual interest rate or a quarterly interest rate, you may be interested to convert it to an annualized interest rate. Then the concept that you use is called the effective annual interest rate if you are using the compound interest, or if you are using a simple interest, if you want to find the annualized interest rate, then the term you use is annual percentage rate or APR. This APR is also called yield for short. How to calculate effective interest rate and the APR. For APR, for example, if the monthly rate was given, so if the monthly rate was given, you just multiply the monthly rate with the number of months in a year, that is 12. While if you want to use the effective annual rate, remember you're using the compound interest idea. So you will be using the EAR is equal to 1 plus R to the power T minus 1. If you will notice here, this one is R is a monthly rate. So monthly rate to the power T, there are 12 months in a year. So you put 12 there minus 1. And that will give you the annualized effective interest rate. Let's take an example. So suppose a monthly rate of 1% is given. What is EAR and what is APR? Remember, for APR you just need to multiply with 12. So I'll start at the bottom here. So it is like 1% into 12, that is 12%. This is the APR. Just multiply with the number of months. For EAR you're going to say 1 plus 10% to the power 12 minus 1, which will give you 12.68. So as noticed, simple interest, usually the rate is lesser than the compound interest rate. You can solve that by using your calculator also, so I'll just skip that. And finally we'll talk about a factor which affects this whole process. So I'll start with the inflation. What is inflation? It's the rate at which the prices as a whole is increasing. So basically it's an economic factor which is linked to the country's rate of, or maybe the prices for its group of consumables. Inflation actually affects the interest rate also, because the interest rate that is calculated without considering the inflation is called the nominal interest rate, while if you also factor in the inflation rate, the rate that you get, or the interest rate that you get, is called the real interest rate. So nominal interest rate is the rate at which money invested grows, and real interest rate, the rate at which the purchasing power of an investment increases. So when we talk about purchasing power, basically we are referring to inflation. Inflation is a big, we can say, factor which affects almost all type of interactions that we have in the financial market. This slide just shows a graph of inflation rate in the USA from 1900 to 2015. The formula to calculate the real interest rate, if you know the nominal interest rate and the inflation rate, so basically you can use an approximation formula, which is simply take the nominal interest rate and minus the inflation rate, and you will get the real interest rate as an approximation. While if you want to calculate the exact real interest rate, then you will use this formula, which is 1 plus the real interest rate is equal to 1 plus the nominal interest rate divided by 1 plus the inflation rate. So basically the approximation formula gives you an approximate value of the real interest rate, but the exact value is given by using this formula. Let's take an example. If the interest rate on 1 year government bond is 6% and the inflation is 2%, what is the real interest rate? So can you see the interest rate is given as well as the inflation is given. So by approximation, 6 minus 2, it's here down here, 6 minus 2 is 4% is the approximate rate. But if I want to calculate the actual rate, we would be taking 1 plus the real interest rate is equal to 1 plus 6% and 1 divided by 1 plus 2%, and bring this 1 to the other side. When you minus that, from 1.039 minus 1 would be 0.039 or 3.9%. So can you see it's almost close to the approximation, but it's not the 4% is not the exact value. 3.9% is the exact value of the real interest rate. So finally, we need to remember that the current dollar cash flows must be discounted by the nominal interest rate, and the real cash flows must be discounted by the real interest rate. So with that, we end the chapter. I hope you were able to understand the concept. We'll be dealing with the exercises soon. As of now, we request you to listen to the recording of this chapter, and hopefully you will raise any questions that you may have. Thank you.